Want to stay young forever? Don't go to space. Okay, that's a bit of an exaggeration, but it's true that astronauts age slightly faster in space than they do on Earth. Weird, right? You might think that being in space, away from the hustle and bustle of Earth, would slow down the aging process. But the reality is quite the opposite. It all comes down to Einstein's theory of relativity. This theory, which has been around for over a century, fundamentally changed our understanding of time and space. It's a real mind-bender, but stick with me. Einstein proposed that time and space are interconnected in a four-dimensional fabric called space-time. This fabric can be warped and stretched by massive objects like planets and stars. Basically, time isn't the same everywhere in the universe. It's affected by gravity. The stronger the gravitational pull, the more space-time is warped, and the slower time moves. Think of it like this. Gravity is like a cosmic speed bump for time. When you're on Earth, you're experiencing a stronger gravitational pull compared to when you're in space. The stronger the gravity, the slower time moves. This is why time moves slower on Earth than it does in the weaker gravitational field of space. So, up in space, where gravity is weaker, time speeds up a tiny bit. This means that astronauts, while they are floating around in the International Space Station or traveling through the cosmos, are actually aging a little bit faster than their friends and family back on Earth. It's a fascinating and somewhat counterintuitive concept, but it's a testament to the incredible nature of our universe and the laws that govern it. I know what you're thinking. Neil, are you telling me time is like a rubber band? Well, in a way, yes. Imagine a rubber band that stretches and contracts depending on how you pull it. That's kind of how time works, according to Einstein's theory of relativity. Einstein's theory of relativity tells us that time is relative. This means that time doesn't tick away at the same speed for everyone, everywhere. Instead, it can speed up or slow down depending on various factors. It's not a constant, ticking away at the same speed everywhere. For instance, if you're moving very fast or if you're in a strong gravitational field, time will actually slow down for you compared to someone who is stationary or in a weaker gravitational field. Time is flexible, influenced by things like gravity and speed. This phenomenon is known as time dilation. The faster you move, or the stronger the gravitational field you're in, the slower time goes for you relative to someone in a weaker field. Imagine you're an astronaut on the International Space Station, moving at incredible speeds around the Earth. Time for you would pass slightly slower than for someone on Earth. This effect is minuscule but measurable with precise instruments. It's like that feeling you get when you're having fun, and time flies by. But in the case of relativity, it's not just a feeling, it's a real, measurable effect. The faster you go, the more pronounced the effect becomes. Except in this case, it's gravity that's having all the fun, messing with time. Near a black hole where gravity is extremely strong, time can slow down dramatically. If you were to observe someone near a black hole, it would seem like they are moving in slow motion compared to you. This concept isn't just theoretical. GPS satellites orbiting Earth have to account for time dilation effects to provide accurate positioning data. Without these adjustments, your GPS would be off by several kilometers. So, next time you think about time, remember it's not just a simple, unchanging tick-tock. It's a dynamic, flexible dimension that can stretch and contract, influenced by the cosmos itself. Einstein's cosmic clock is a fascinating reminder of how interconnected time, space, and gravity truly are. Imagine two identical clocks, one on Earth and one in space. The clock on Earth is experiencing stronger gravity than the clock floating around in orbit. Now, this difference in time is incredibly small, mind you. We're talking fractions of a second over an astronaut's entire career. But it's measurable. It's like a tiny cosmic time warp. When astronauts return to Earth, they're technically a smidgen older than they would have been if they had stayed on terra firma. So, what does this all mean for our understanding of time? Well, it throws a wrench into the idea that time is a rigid, unchanging concept. Time is more fluid than we realize. It's all relative to your position and speed in the universe. It's like the old saying goes, time flies when you're having fun. Except in this case, it's gravity that's having all the fun, warping time and messing with our perception of reality. Section 5. Life in the fast lane. Think about it. If time is relative, does that mean we experience it differently depending on our lifestyles? Imagine the life of an astronaut, constantly moving at incredible speeds, orbiting the Earth every 90 minutes. Their perception of time must be unique, right? What if you're an adrenaline junkie, always on the move? Whether you're skydiving, racing cars, or exploring the depths of the ocean, your life is filled with excitement and constant motion. Does this fast-paced lifestyle make time feel like it's slipping through your fingers? Do you age faster because you're constantly living life in the fast lane? The theory of relativity suggests that time can indeed be experienced differently depending on your speed and gravity. But in our everyday lives, these differences are so minuscule that they are hardly noticeable, probably not in any measurable way. However, the idea that our perception of time can be influenced by our activities and environment is fascinating. When you're busy and engaged, time seems to fly. When you're bored or waiting, it drags on. But it's a fun thought experiment. Imagine if we could somehow manipulate our perception of time to make the most of every moment. Would we choose to live life in the fast lane, or would we slow down to savor each experience? Maybe the key to a long life is to take things slow, relax, and let the cosmic time warp work its magic. Or maybe not. Perhaps it's about finding a balance between the fast and the slow, the exciting and the calm. But hey, it's worth a shot, right? Whether you're living life in the fast lane or taking it easy, the important thing is to enjoy the journey and make the most of the time you have. Section 6. Can we hack time? So, if gravity can influence time, can we control time by manipulating gravity? That's the million-dollar question, isn't it? We're a long way off from building time machines or manipulating gravity at will. But it's something that scientists are actively researching. Imagine the possibilities. We could travel to the future, visit distant galaxies, or even go back in time and meet our ancestors. The future of time travel is looking bright, or should I say, relative. Section 7. The power of now. But even if we can't control time, yet, there's still a lot we can learn from this cosmic quirk. It reminds us that time is precious and that we shouldn't take it for granted. Instead of worrying about aging, maybe we should focus on making the most of the time we have. Live in the present moment, savor every experience, and don't sweat the small stuff. After all, time is just an illusion, right? Section 8. Mind over matter? But here's another mind-blowing thought. If our perception of time can be altered by external factors like gravity, could our internal state also play a role? What if our thoughts, emotions, and beliefs could actually influence our experience of time? It might sound far-fetched, but some studies suggest there might be a connection between our mental state and our perception of time. Maybe time isn't just about physics and gravity. Maybe it's also about our state of mind. Section 9. The universe in a grain of sand. These mind-boggling concepts about time and gravity might seem like something out of a science fiction novel, but they're very real, and they have profound implications for our understanding of the universe. It's a reminder that the universe is full of mysteries, and the more we learn, the more we realize we don't know. It's enough to make your head spin, but in a good way, of course. Section 10. The final frontier. So, The next time you're feeling stressed about time flying by, just remember, it's all relative and ever-changing. And who knows, maybe one day we'll figure out how to manipulate time to our advantage, unlocking new possibilities. Until then, let's make the most of the time we have and keep exploring the wonders of the universe together. After all, the universe is a pretty amazing place and we're just along for the ride. Keep looking up and dreaming big.